everyone, my name is Timothy Harris, and today I'm here with Dr. Fukami. Dr. Fukami is an evolutionary biologist with a specialty in ecology. So Dr. Fukami, I've already introduced you, but I'd like to ask, who are you and what do you do?
Okay, yeah, my name is Tad Fukami. I'm a professor in biology department here, and as you said, I'm study ecology, and particularly what we call community ecology, which is the study of species in ecosystems interacting with one another, and we try to understand how those species interactions overall are going to affect the membership of the ecosystems. And particularly, I've used different ecosystems for this work, but current work particularly focuses on the microbial communities like bacteria and fungi that we find in flowers, and then we think about flowers as tiny ecosystems that are made up of those microbes, and we use that to try to understand the general principles about community assembly.
So what do you think happens when there's a disequilibrium in community assembly? How does nature revert itself back into equilibrium?
Yeah, so this idea of equilibrium is a very interesting one, and we tend to think that the ecosystems are in equilibrium with some good balance, but in reality, that's not often the case, because the ecological communities are in constant flux. And so, as you say, for example, if there are some predators come, that might disturb the communities, and then there might be some empty places where new species can come. And so often there's a lot of turnover of species because of those species interactions happening in ecosystems. And so I would say that the communities or ecosystems out of equilibrium and disequilibrium is mostly what we actually see in nature, rather than ecosystem in equilibrium. So dynamic changes happening all the time.
So what are you currently studying in your lab right now in relation to evolutionary biology or ecology?
Sure, yes. And so, as I mentioned, we study many different things, but the main focus at the moment is this microbial communities in flowers. In relation to evolutionary biology, we are finding that how, for example, this particular species of yeast, the fungal species, and particular species of bacteria that we often see in the nectar of flowers, they actually can undergo some rapid evolutionary changes, so that as they interact and influence each other, their characteristics can change evolutionarily, so that there's genetic change more rapidly than we used to think. And so one of the things that we are doing is to try to understand how this rapid evolution of characteristics of these microbial species affect the relationship with one another, and how that could also affect the nectar chemistry, for example, that can in turn affect the pollination, because in our case, hummingbirds come to these plants that we study, but we are finding that when microbes change the chemistry of nectar, the hummingbird preference of which flower to go to get nectar is influenced, because sometimes, for example, that when there's specific bacteria that are colonizing flower, they can make the nectar very acidic, and hummingbirds don't like that so much, and so they go to another different flowers, and so in turn there is some effect on plants as well, because the pollination is influenced, and then the number of seeds that the flowers can produce depends on the pollination by hummingbird. And so hummingbirds are influenced by what's happening in microbial communities in nectar. Then the pollination is also influenced, and so those are the things that we are trying to understand at the moment.
Seems very cause and effect. So it seems like as an evolutionary biologist, you get to travel all over the world, place to place to place to place. where have you traveled where you've seen the most significant effect on evolutionary biology, or it's just transformed your whole intake of evolutionary biology itself?
Yeah, so I don't know where. So as you mentioned, yeah, I got to travel and then went to different places for research. That's I've been very fortunate. I'm not sure. Evolution happens all the time and in everywhere, and so I can't really tell where the which place might have most significant evolutionary effects happening. But in terms of where which place has been particularly impactful to me, I would say that long time ago I was a researcher in New Zealand, and I got to travel to many different islands to do an ecosystem research to look at how the rats as introduced species, how they are affecting the native ecosystems that you see on many different islands in New Zealand. And so it's a beautiful islands that I got to go with other people that were involved in this project, and I think that's the most spectacular place that I've been to for research. Yeah.
So you got your undergraduate from Japan, and then you come to the States, to America, to teach evolutionary biology and ecology. So what influenced your decision to leave Japan and then come to America?
Sure, yeah. So, yeah, as you mentioned, my undergraduate school was in Japan, in Tokyo. But I got lucky because they had an exchange student program for you. I could apply to come and spend 1 year in a small liberal arts college. I went to Wisconsin for a year as an exchange student, and so it was a big struggle for me because Japanese and English are so different as languages, and so at first, initially, it was very hard for me, but the 1 year was long enough for me to eventually get used to it, and I started to enjoy being in the US and having a culture that's different from what it was in Japan. And so that year was very influential to me, and I wanted to, because I enjoyed it so much, I wanted to have some reason to come back to the US. And so I thought that going to graduate school would be a good excuse. And so I got very interested in trying to go to graduate school in the US, and that's how it happened. And I just mostly ended up staying in the US, although I also have close ties to Japan too now.
So did you always want to be an evolutionary biologist since you were young?
I think so. I grew up in a suburban area near Tokyo, so there wasn't much nature there. But I had my grandparents lived in the countryside, in a beautiful countryside in Wakayama Prefecture, and my parents often took me and my brothers to spend summer there, to be with our grandparents, and there's really beautiful mountains, and the sea was very close, and so I was catching insects and looking at the tide pools, and there were some relative who was nice to take us to fishing in the sea and with on the boat, and that experience, I think, was very I really liked it, and I think what I do as evolutionary biologist or ecologist, field biologist I do now, is basically just an extension of my childhood interest. And so I think I was already more or less knew that I would be a biologist then.
Okay. So within the next 6 months, let's say I have enough money, where should I go vacation in Japan?
Yeah, I don't know. Anywhere would be good. I think more than location, I would suggest the particular time of the year to visit. I think summer wouldn't be a good time because it's very hot and humid, and unfortunately with this climate change continuing, it's not going to be present to go to Japan in summer, and so either winter or May, about this time, October, November, would be a better time to go.
If you had only 3 years to correct all the problems in evolutionary biology, where would you start and how would you implement that?
Very difficult question. I think it's more than research frontiers. I might, in relation to evolutionary biology, I might try to think about how we can correct, particularly in the US, evolution. Not everyone thinks evolution is real. And so I think I will try hard to see what I can do to correct that misconception. I think it's not so much about research frontiers, but just for the general public understanding of it. And in a kind of similar way, it's not so much about evolutionary biology only, but another big, of course, problem is climate change and climate crisis. And so rather than doing research, I think I would try hard. I'm getting more and more interested. You cannot be interested in this now with the climate crisis. I would try also, if I only have 3 years, I would focus on trying hard to think of what contribution I can make to make this climate crisis more of a mainstream concern that many more people would think about as a serious problem.
Understood. So I'm in Stanford, California. Where's the best place to eat here?
There's one good restaurant I would recommend, and it's a Pakistani restaurant. It's really good. They have really good food, and very close by, just 10 minutes off campus. And so that would be a place I would recommend.
Thank you. So what's the most challenging part of being an evolutionary biologist? Being in your position, being a professor, having your own lab, and just having to show up to work every day and exhibit a certain level of professionalism. What's like the most hardest part about doing all of these things and doing them well?
Yeah, it's mostly enjoyable and exciting. And so I don't think so much about challenging part, but I guess it's all both challenging and rewarding is the thing that the research can be hard. And so you have this assumption of some ideas of how, for example, ecosystem work, and you try to get data to confirm your intuition. But it doesn't work because we don't have a good understanding, and so when we get data, we get things that are not very that we didn't expect, and we have to think about why, and it can take time to get to a good understanding, and so I would say that's the challenging part. But I think it's also when you once you understand, that's also exciting. And so it's both challenging and exciting part. The research, how difficult research is I think the most challenging part, I would say. Yeah.
So what hobbies do you like to do?
I used to play soccer a lot, but I don't so much, but I follow professional leagues and the national games. And so I would say that's one hobby that I have. And I also play piano, not so well, but that's another hobby I have.
So who do you go to whenever you have an issue or a problem? Who's that person that you look up to, be like, oh, I need help on this?
I think my colleagues, and so one person might be somebody in the next office, and his name is Kabir Pei. He's another professor here, and we share a lot of interest in research, but also personally we're very close. And so I think he's one of the people that I go and talk to when I have some problems.
So where do you see yourself within the field of evolutionary biology within the next 5 to 10 years?
Yes, good question. I have a new interest, and I felt like I'm kind of late in my career to have a new interest. But I think you can never be too old to start something new. And my new interest is traditional. Often it's called traditional ecological knowledge, which is the indigenous worldview of about ecology and how, in contrast to Western scientific approaches to understanding nature, the more traditional indigenous way of understanding how people interact with nature and how ecosystem function, that's different from traditional scientific way. And I think to me, I'm getting more interested in understanding traditional ecological knowledge because I think it's one of the key things that we have to understand more to solve issues about climate change and climate crisis and different associated problems. And so it's only a new interest, and I don't even know how to make that into my research efforts. But I would like the next 10 years, I really like to think more about traditional ecological knowledge.
So, what advice do you have for the next generation of STEM scientists?
Okay. What advice? I can speak from my experience as an international student coming to the US, and particularly those, but I hope this is not just for the international students, but also the students from the US too. I wasn't very confident about my ability to be, I didn't think that, for example, I could do PhD. That seemed too hard. But I think I had some people that I was fortunate to meet who were very encouraging and saw in me some potential, and they guided me through that. And I think the advice would be that if you are not confident about, or if you're not sure about your ability, I think it often just takes meeting somebody who would understand you well and could tell you what are the strengths and weaknesses that you have, and what's the potential that you have, and I think meeting those people is, I think, important. It was at least important to me, and so I would just try to. I tend to be, I guess, shy myself, but I would try to meeting a lot of people and talking with them. Some of them will be important to you, and so that would be my, I think, trying to meet a lot of people and talk to them would be my advice, I think.
Yes, sir. Well, Dr. Fukami, I want to thank you for responding to my email and agreeing for an interview. We do appreciate you having it on, and I really enjoyed your story, and I hope more students can find it and become inspired for it. Thank you.
Thank you very much.
Thank you.